So example 3 says you're supposed to solve by completing a square when a is not equal to 1. A just means your leading coefficient. So in this case, they've got a negative 1/2 here. And in this case, they've got a 3. So the last one we did, it was just x squared. That was easier. This one, we're going to have to deal with it. And the easiest way to deal with it is to get rid of it. So I'm going to look at this question and decide what I need to multiply everything by to get rid of negative 1/2 and turn it into 1, because then 1 is just x squared and it's fine. So it turns out that if I want to go negative 1/2 times what equals 1, then I could do guess and check, or I could move things around a little bit. You could use your calculator and go, well, if it's being multiplied on this side, then you could divide it. So you could make it go over here and go divide it by negative 1/2. You could use negative 0.5. It doesn't really matter how you set it up at this point. You're just trying to find the number that multiplies by negative 1/2 to get you to 1. And the answer is going to be negative 2. Negative times a negative is a positive. 2 times 1/2 equals 1. So what I'm going to do then with my original equation is I'm going to multiply all of it by 2. So negative 2 times negative 1/2 x squared plus 6x minus 1 equals negative 2 times 0. See, we did it to both sides. But what you see happening is this is still just 0 because everything is 0 multiplied by 0. And this side becomes, these guys cancel out, which was what we wanted to do in the first place. X squared negative 2 times positive 6 is going to be negative 12x, and negative 2 times negative 1 gives me positive 2. So now I have a slightly different equation, and yay, it's in the same format that I've seen before with there's x squared by itself, and then these numbers, there's no fractions or anything like that. So that's nice. So now I go on to my completing the square as usual. I go, okay, well, I got to move this over here to become a negative 2, and I'm going to cut this in half. So I'm going to have, this is going to be negative 6. I'm going to square it, and 36 is going to go there. So what I end up writing out is that x squared minus 12x plus 36 is equal to my negative 2 that I moved over plus 36, because that's the number I had to create in order to have my perfect square. Now the perfect square trinomial that I have is going to be at x minus 6 squared, and it's going to be equal to 36 plus negative 2, so 34. Now to get rid of this, I've got to take the square root of each side, which leaves me with x minus 6 equals the square root, equals the square root of 34. 34 is a prime number. Actually, it's not a prime number, but it doesn't have any factors that are a perfect square, so we can't really simplify it any more than that. So all I do now is I move my negative 6 over as a positive 6, and I'm left with x equals 6 plus or minus the square root of 34. So that one's done. Let's just draw a little line here so we're not getting in the way. Now this one starts with 3x squared. So what do I multiply 3 by to get to 1? Well, maybe it's easier to think of it as dividing, I don't know. But I've got to go 3 times something equals 1, because I need to make this 1. So here's a good way to just use your normal operation of doing things. 3 times something equals 1, so 1 divided by 3 will give you the answer. Oh, look, it's a third. A third of 3 is 1. Perfect. So that's the answer that I'm looking for. You could use 0.3 forever if you want to, but obviously you're going to be rounding that off. So 1/3, keep it in a fraction form, is going to be more helpful. So now I'm going to do the same thing I did over here. I go 1/3 times 3x squared plus 9x plus 5 on this side is equal to 1/3 times 0, which is still just 0, but these numbers are all going to change. I'm going to have x squared, 9 times 1/3, or divided by 3, equals 3x, and then 5 times 1/3, this is a little bit yucky, but it's going to end up being 5/3. Please don't use decimals. Now, I've got to move my 5/3 over, so it's going to become negative 5/3 on that side. And I'm going to need to go x squared plus 3x plus something equals the negative 5/3 plus the same something. In order for this to be a perfect square trinomial, I got to figure it out and go 3 divided by 2. Your book actually wants you to use 3/2, not 1.5. So 3 divided by 2 is just going to be 3/2. If I square that, then my number here is actually going to be 9/4 because, and it's positive, because 3 squared is 9, 2 squared is 4. So this would be like 3/2 times 3/2, which equals 9/4. Don't be too worried about it. Not a big deal. We'll just keep going. That means I have to add 9/4 to this side as well. So this whole thing reduces to x plus 3/2 squared is equal to, we have to add fractions. Okay, that's not so hard. We just have to make the denominator the same. So 3 times 4, 4 times 3. If I do it to the top, I do it to the bottom, bottom, top, same thing. So this whole thing is going to be negative 20/12 plus 27/12, which is going to give me 7/12. So I'm going to take that number and put it on this side, and I've got 7/12. Now I follow the same steps I did here. Take the square root, of each thing. Don't worry that it looks complicated. You're following the same steps. You're not going to have to worry about it too much. It's just going to follow the pattern. So this becomes x plus 3/2. This becomes the positive or negative square root of 7/12. And then I just move my 3/2 to that side. It becomes a negative. So I'm left with x equals negative 3/2 plus or minus the square root of 7/12. Now, if your book wanted to be fussy, it could make you solve out the 12, and it would be 1/2 times root 7, but they don't. They just leave it, or whatever. You could work that out on your own, but your book is merciful. They just leave it as root 7/12. Oh.